focus on the data part, SQL data. Yeah. Before we write our SQL queries, we like to understand the SQL data, some important properties. Yeah. B.1, numeric and string data. Yeah. Just the basic properties. Yeah. I use example, give you last time I used that, the university example. I talk about some simple difference between numeric data and the string data. Yeah. Let us look at the numeric data type first. Yeah. The first, integer data type. Integer numbers of various sizes. Capital integer. Yeah. Here, remember, the capital or lowercase, it's not case sensitive. First, we know, not case sensitive. Yeah. But many times you see people write in capital or upper cases due to the, for the keywords, SQL keywords. Many people like to write them in upper case or capital letters, sometimes for convention, sometimes for preference. Yeah, because we can see later many places when we write these data types in our table design, we use lower cases. Most of the time, we use lower cases. Yeah, so you will see. Yeah. Yeah. All right. Integer or int, small integer, with various sizes. Yeah. 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 But here, most of the time, we use the int case. Yeah. Int case we can cover from small sizes to larger sizes. So very convenient. Yeah. Let's look at this example. This one, for the line field, it is of integer type, int type. You can see here people use lowercase, right? Int. Yeah. And parenthesis 2, that means 2 digits, up to 2 digits. Yeah. Not exactly 2 digits, up to 1 digit is fine. Okay, within the range. Yeah, but you cannot use 3 digits. Yeah. Maximum 2 digits. Parenthesis 2. Yeah. You can see this is small size. Yeah. When you need a larger integer size, 20, 40, you can put a number there. Yeah. So even larger size, you can put a relatively large number there. Yeah. All right. Default, yeah, here you see the capital default. Yeah. Yeah. But data type, int, most of the time people use the lowercase. Yeah. All right. Default single quote 0, you can understand the meaning if we do not provide this line value, they just use the 0 value. Yeah, so that's the default. Yeah, so you do not have to provide a value. When you insert data, if the default value is provided, then you do not have to provide any value for this particular field. Yeah, so there is no error. Yeah. All right. Next one. Sorry, yeah, this one, another problem we have, remove that not. Yeah, when I do editing, yeah, because in PowerPoint slides, when I copy with different font size, sometimes I may mess up. So I have to leave some old word first. Yeah, then if I forget to remove it, then you will see it. Yeah, all right. Floating point real numbers of various precision. For floating point, we need to provide precision information. Yeah. Yeah. You can use float, capital float, real, double, yeah, here although capital, but when you use them, yeah, most of the time people use lowercase. Yeah. All right. Double precision, double, yeah. All right. And formatted numbers can be declared by using decimal parentheses, like, you know, two parameters, I and J. Yeah. For float, you also use the same way. Okay. Yeah. For double, you also use the same way. Okay. Yeah. Two parameters you can use to control the precision. Okay. Yeah. All right. DC numeric. Yeah. Here, let me give you simple. Yeah. Let me just explain. Precision, I gives us the precision number. What's that precision number? The total number of decimal digits. Total number of decimal digits. Before the decimal point, after decimal point. Yeah. Here, let me put it, suppose this is a decimal point. Okay. We have some digits before the decimal point and some digits after decimal point. These two parts adding together, okay, that's the I part. I part, right? Yeah, before and after together, all right? Yeah. And the J, we call the scale J, the number of digits after the decimal point. Okay, after decimal, that's the J. Okay. So then the number of digits before the decimal point, I minus J, right? Yeah. Okay. Yeah. Yeah. All right. So then later you can use this way and you can understand, you know, other people use this way to represent floating point numbers. Yeah. All right. Next, character string data type. Yeah. There are two different ways people can specify this type of data. Yeah. The first type, called a fixed length. Fixed length. Yeah. Yeah. So CHAR parenthesis N or character parenthesis N. Yeah. Yeah. So and the number of characters must be the same number of characters, not the maximum. Okay. Yeah. If you do not have that many characters, that's a violation. That is a, you know, violation. Your data won't be entered into the database. Okay. Yeah. So fixed. That's why we call it fixed length. Yeah. Varying length. Varchar, VARCHAR, parenthesis N, and some other ways to write it. Yeah, but the first way is the most popular. Although there are multiple ways to write the same data type, yeah, we because the first one very convenient. Yeah, this one varying. Yeah, its length is not fixed. That N is the maximum number. Yeah, so if you have fewer than that number of characters, yeah, that's perfectly all right. And in our real world applications, most of the time we use the varying length data string data type. Yeah. Flexibility, most of the time we can set the maximum number, but we do not need to use that many. Yeah, we do not need to use that many. Yeah, up to that number. Yeah. All right. Look at this example. Content. Sometimes we want to enter some content. For example, for math problems, I want to create a table to store math problems. So I need to store the content of the problem. Okay. Then I need to consider, how many characters should be enough when I use that field, content field. Yeah. Here I set 3,000 characters. Yeah. Yeah. It may not be enough. You can have a big problem description, big question description. You may need more than that many characters. That's possible. Yeah. But for most of the time, 3,000 characters, for the typical case, yeah, more than enough. Okay. Yeah. Then some related question. Yes, related question. First, because here you specify this maximum number. Yeah. If we do not use that many characters, is it the case that the DBMS can save storage space? The DBMS does not need to make that much space. Although so here we know, this is 3,000 characters. Okay? Yeah. Here, what I mean is inside DBMS, it's not like you make a reservation. Yeah. When we declare 3,000 characters, we make a reservation in DBMS. We need to we get a reservation of this many characters. It's not like that. If you use only small portion of it, then the DBMS will only consume the memory of this much. Okay, yeah, don't worry. The DBMS automatically saves the remaining space. Yeah, no waste here. The remaining space will be saved. Yeah, yeah. So that's one thing. Now, another possibility. Yeah, we also need to consider. So that is, how about when the length of content? Later you will see length, that is a function. Yeah, we call it a function, a SQL function. In SQL we have many functions. Yeah. So length of content. How about length of content greater than 3,000? That could happen. Right? That could happen. Yeah, greater than 3,000. So we know past the maximum limit. Then the consequence. What is the consequence? There are several possibilities for the consequence, right? First, error message. This is something like overflow. You hit some overflow. We know when we do computations, usually in a computer, when we have an overflow, we will get an error message, runtime error, overflow, right? Oh, sorry, that's not. Yeah, overflow. It happens without warning. Overflow, if you have an overflow in your computation, it happens without warning. So people won't know it, all right? Or you have an overflow, yeah, the overflow part truncated without warning, all right? Without warning, okay? Yeah, that's the way. And here, you have this case, truncation. Truncation happens, only takes the first 3,000 characters, remaining part truncated, throw away. You will lose data, all right? So that's why you should be very careful, right? When you set that upper limit, be careful if you set too small, then if truncation happens, then you need to protect your data. Okay. Yeah. All right. All right. So that's B.1. B.2, understand null value. Yeah. We cannot avoid that. This value happens in many cases. So first, we need to understand the nature of this value, its properties. In our programming language, we need to deal with null value, right? For example, in Java, null value. When you declare an object, before you do initialization, instantiation, you can assign a null value to an object. Okay, yeah. But in our SQL, so here, our environment is the SQL programming language. We just treat SQL as another programming language, okay, similar to Java. Then its rules quite different in SQL, right? Yeah. Let us learn the basic properties of null value. So what is the null value in SQL? Why we need this special value in SQL? Yeah. Null is used to represent a missing value. In general, so it's a missing value. You may have that situation for various reasons. You cannot provide its value when the data is entered. Okay, yeah. But for other pieces, you still want to insert data for other fields first. Yeah. And this missing value, you can fix it later. Okay, yeah. That could happen in the real world. So we need to allow it, the special value. Yeah. But that is usually as one of the 3 different interpretations. 3. Yeah, 3 different. Yeah, let's look at these 3. Yeah. The first one, unknown value. Its value exists, but not known. Yeah. Yeah. Some students, ID, student number, when the data is entered, yeah, but, it's not available, couldn't get that ID number. Yeah. In that situation, okay, yeah, you have to put something there, right? Yeah. You have to put something there. Yeah. So null value is an option. Yeah. Here we can say it's an option. You may have other options, yeah, but here null value is one of the options you can use here. Yeah. Unknown value. The second case, unavailable or withheld value. Okay. Unavailable, withheld, yeah, exists, but is purposely withheld. Yeah. I mean, very sensitive, it is not exposed to ordinary people, let's say in this way, right? Yeah. Just, for some reason, yeah, that kind of very important, highly secret value, not exposed to ordinary employees. How about that? Yeah. Yeah. So withheld, yeah, then put this, another case, yeah, null value. Okay. So when you see null value, this is one of the possibilities. Okay, all right. Number 3, not applicable attribute. Yeah. So so that's the not applicable, right? Yeah. So you ask this value, but for this person, it does not make sense. Okay. That's possible, right? Yeah. Not applicable. That's the third case. Attribute is undefined for this tuple. Yeah. For this particular entity. Yeah. This tuple we know refers to some entity, right? Yeah. Yeah. And more than that, usually entity. Yeah. Relationship, it's possible, right? Yeah. We know entity relationship. Yeah. Yeah. Relationship, you can also use null value, right? Yeah. All right. All right. Yeah. These 3 typical cases. Yeah. You may argue, some people may argue, for their business, they may have more than these three cases. That's possible. Yeah. Because your business could be very special, right? Yeah. Not in one of the three typical cases. You may have case number 4, number 5. That's also possible. All right. Yeah. So you define those cases. Yeah. All right. Why use null instead of some special value? Yeah. So this question, because sometimes people may use 0. That's one thing. Yeah. So other than null value, in some of the situation, one option that people can use 0 is 1. Another, for string value, empty string is another one. Yeah. If the value is not provided, empty string, right? And sometimes -1. Yeah, because if you use 0, that 0 probably is meaningful, right? When sometimes 0 is meaningful. If 0 is meaningful, but that value is not provided, you use 0, then you may get a wrong interpretation. So you may use some, -1 under that kind of environment. It does not make sense. So you tell people, it is like a warning, okay? You just put something to get people alerted. So you need to do something here, all right? You need to do something here. Yeah, it's unusual. Some things you need to fix it. Yeah. That kind of situation. Okay? Why use not instead of some special value? All right. Make users aware of it. Yeah, that's one thing. Because if you use other values, yeah, users may not be aware of it. Yeah. When you see 0, see empty string, see it's a normal value. I do not need to do anything, right? It's normal. I do not need to fix it. Okay, yeah. But null is different. When you see null, yeah, actually in your database, when you see null, it is just a capital case like this. Yeah, yeah. In this way. Yeah. So when you see it, yeah, at least you need to think about it. All right. Yeah. Okay. Yeah. The DBM treats it differently from other values. Later, when you do queries, when you encounter null values, the behavior will be different. Behavior will be different. Yeah. So that's the reason we need to study this value carefully. Otherwise, later when you do the queries, so you will get a lot of unexpected results. Yeah. All right. All right. Handling null values in DBMS. Okay. Yeah. So you can see we spend a lot of time to study this one. Yeah. Because it's important. Yeah. Its impact on many queries. Yeah. So later, yeah, we have to do some careful treatment for the special value, null value. All right. Who determines the meaning of null? Regarding the 3 different interpretations in our previous slide, who determines one of the 3 interpretations? Yeah. All right. First, non-SQL. SQL is not responsible for that interpretation. Okay, SQL does not know anything. So which one of the 3 cases you are talking about? SQL does not know it. All right. SQL does not distinguish among the different meanings of null. All right. Yeah. Not DBMS. Okay. DBMS is not responsible for that interpretation. What is the meaning of null? DBMS, does not need to do anything special. Just treat it as a null value. Okay, for whatever reason, just it's a null value. Okay, DBMS. People who are familiar with the business rules, they need to determine the specific interpretation. Yeah, because it could be hard. Yeah, you need to be very familiar with your business. Okay, yeah, all right. Different individual null values now, because this value is so special, then you need to do comparison with null values involved. Compare values, but you have certain number of null values. When you do comparison, what is the typical behavior? So we need to understand that part. So each individual null value is considered to be different. Yes, so that's special part. Two null values are treated as different values. How about that? From every other null value by the DBMS. Okay, yeah. All right, for example, row 1, you have 2 rows, row 2, all right, okay, yeah. And row 1, row 2, they have different field, all right. So for this field 2, right, they happen to have both null value. From the appearance, they both show the same spelling, null value, okay, same spelling. But these two, they are treated as different values. Different values, yeah, okay, yeah. So that's why it is special. That's why when you run the query, you should be very careful, right? They have different values. Think about, suppose we have the situation unknown case, right? Row 1, row 2, unknown case. The values for this field number 2 unknown, so you need to find them later. When you need to find those 2 values, there is a good possibility those values could be different. Definitely there is another possibility they could be the same, right? Yeah. But because they could be different, so the DBMS automatically treat them as different values. When they compare, if you really need to compare equal, the result will be unequal. Okay, the result will be unequal if we really compare null with null, unequal. Okay, not equal. All right. The comparison logic is different. Then, when we do comparison, let's think about this. Let's think about this. All right. So here, in SQL, when you do comparison, equal value comparison, you use single equal sign. All right. Not double equal. In our programming language, we use double equal, right? In programming, we want to compare A with B. If they have the same value, we use double equal. That's the programming language. But a SQL, single equal, when you do comparison, not double, all right? Yeah, you may feel, assignment, right? Single equal assignment, yeah. But, yeah, so here, comparison, single equal, all right. But here, if you compare null single quote with null value, you will true or false. You will get a false. because they are treated as unequal. Right? When you do this kind of comparison, the Boolean value will be unequal. The Boolean value will be different, or will not be true. First, just let you know, the Boolean value won't be true. All right, false or not, we will see later. False or not, that's another issue. Okay, won't be true. Yeah, all right, won't be true. All right, okay. But the question is, how do we check if a field value is null or not? How can we check it? Yeah. You cannot use the equal sign to check it, right? If you equal sign, you won't get it, right? You won't get it. So you cannot use equal sign to get it. So that's why comparison logic will be different. Yeah. You need a special way. So you need to use is operator, is null, all right? Yeah. Some field, well, you need to check if that field takes the null value or not. You should not use the equal sign as the comparison operator. You need to use the is operator. That is an operator, all right? Yeah, that, so is null, then DBMS will tell you if that value is null or not. Yeah. Yeah. So that's the special property of this one. So a special comparison operator is, that's the operator, is operator. Okay, yeah. All right. B.3, other data types, other than numeric and string. Yeah. Then we may have other data types. Why languages? Yeah, it's not a language. It's not, the title is not right. Anyway, all right. So it should be other data types. The title should be other data types. All right, okay. Boolean data type, the first one, yes. The Boolean true, false, but in our SQL, we have third value. 3-value logic is used. True, false, third one, unknown. Think about that, unknown. Why unknown? Yes, because of the null value. Think about when you do comparison, if one of the values is null, what should you get, right? True or false, right? Yeah, let's take a look. Because of the presence of null value. Okay, yeah, think about, all right. Think about the situation when you compare A equal null, A value, okay? A value equal null, true or false? Think about that. Because the meaning of null, unknown, it's true value will be resolved at later sometime, right? Yeah, its meaning, its true value will be available after some more work. It will be available, But before it is available, can you say this comparison is true or false? You cannot say true because that value could be different. You cannot say false because that value, there is a possibility that value could be the same as A's value, right? There is a possibility of that. So then, to be 100% safe, you just give unknown value because it is unknown. Unknown means it could be true, it could be false. All right? Yeah. There is a possibility to be true, there is a possibility to be false, then it is unknown. True means 100% true. False means 100% false. all right? No fuzzy place, you know, yeah, 100%. If it's not 100%, you use unknown, okay? Yeah. So that makes the SQL logic more complex than our usual programming logic. Programming logic, we only have true and false. We do not have unknown case, okay? All right. Data type, yes. You also need to represent date, okay, data type. But in SQL, the data type is quite different from our everyday life date representation. The reason is very simple, because SQL is for the people of the whole world, not for any particular country, right? SQL is used by people on Earth, yeah, not only work for one particular country, yeah. And we know the date format for different countries will be different, right? So different, so many different ways, yeah. So then SQL takes this format, okay? 4-year digits first, then dash, okay? Not a slash, you know, not a, you know, other symbol, yeah, just dash, yeah. Then MM, yeah, MM, although here we see 2 digits, right? Yeah, but if you use 1 digit, it's also legal, all right? Yeah, but here it's 2 digit, MM dash DD, okay? If you use 1 digit, an M part, a D part, you know, DBMS can make it right, okay? The DBMs can make it right, yeah, yeah. All right. Yeah. Time data type. Yeah, similarly for time, we need to take a format, but this one, yeah, just as usual, okay, use colon to separate hour part, a minute part, and a second part, yeah, separate by colon. Yeah. All right. Then date and the time. Sometimes people want to combine these 2 types as one integral type. Yeah. So they call it date-time format. Yeah. The name of the data type called a date-time. Okay, date and the time. Yeah. Because when you do the declaration in when you define your table, you need to declare that data type. So you call it date-time type, okay? Date, time, time as one word, one keyword, one SQL keyword type, okay? That is, so you first, you do the format of date, but leave a space between date and the time, a space between them, okay? Yeah, so that's the date-time format. Okay, yeah. All right. Then part B.4, compare values. Yeah. Now we need to do some comparisons. Yeah. All right. Compare value, general comparison. Yeah. Equal sign, not double equal comparison. Yeah. For exact match. Yeah. No order for comparison field is required. Yeah, here, yeah. What's the meaning of this? No order for comparison field is required. Yeah, that means for exact match, you do not need to even define the order of the given data. Yeah, some data there is an order. Numerical value, you have an order. String values, you have an order, right? Can you imagine for some special data, you may not be able to define an order, okay? That's possible, yeah. There is some special data types, there is no order available. That could happen, all right? Even that happens, no order definition. You can compare if two values are equal or not with exact match. Because you don't need to know which one is larger, which one is smaller. You only need to compare bit by bit. They are exactly the same. Okay, yeah. All right. Without order definition for the field, it still works. Yeah. Exact comparison. Yeah. Yeah. Okay. Order, most of the time, our data types, we can have a natural order in our data types, but you need to allow there are some very special data types. There is no order definition. Okay, yeah, yeah, all right. Less than, greater than comparison, then you have to, the order must be defined for that data type. Yeah, less than, greater than, this time, order is important. Okay, yeah. To get order information between two values. And order must be defined. Yeah. Otherwise, you cannot. Yeah. Otherwise, you will have some problem. Yeah. If there is no order definition, you cannot do this kind of comparisons. Yeah. Yeah. All right. Okay. But you can still do the equal sign comparison. Yeah. All right. Yeah. Compare values for individual data types. Here we need to know the order, natural order. Okay. Numerical data type, that's easy, the natural value order. Yeah. Yeah. But for character string data type, also natural order, yeah. Alphabetic order. Yeah. Alphabetic order. Yeah. But here, alphabetic order, numerical order, quite different. Yes, here. Yeah. Because alphabetical order, we need to compare character by character, right? We need to compare character by character. Think about that. For numerical value, we just compare as one value, right? We do not compare character by character, or digit by digit. When we compare numerical values, we do not compare digit by digit. Yeah. We just compare numerical values. Okay, yeah. All right. There is a numerical value, comparison. Yeah. This means numerical comparison is faster than string comparison. Okay, this tells us, yeah, numerical comparison is much faster than string comparison. Okay. String comparison. If you know this property, yeah, because this property is important, so I emphasize here, because the performance is very important. Yeah. When you work in some business, performance is really important. If you can save 1 second or fractional second, still it is valuable, right? Because that could be accumulated, okay, to be a lot of time. Yeah. Then that means, yeah, the reason I emphasize this part, because sometimes the same number could be stored as the numerical value, and it can also be stored as the string value, right? For example, 1, 2, 3, you can store as a numerical value. You can also store as a string value, right? String 1, 2, 3, right? Yeah. Yeah. But when you have that option you need to think about. If you need to do comparison, you can get a faster comparison if you use the numerical value, not a string value. All right, yeah, so that's important. Yeah, all right. When a string value happens to be a number, do not get confused with these two orders. Yeah, because suppose that 1, 2, 3. Yeah, all right, so here, let me explain this property. When a string value happens to be a number, yeah, that 1, 2, 3 happen to be not. Do not get confused with these two orders. What two orders? Numerical order and the alphabetic order. Okay, that's totally different because let me use another one. Another 2, 3. Okay, but when you compare these two strings, 1, 2, 3 and a 2, 3, 2, 3 will be larger, right? Yeah. Because the most significant digit is 2. 2 is greater than 1. So in alphabetic order, 2, 3, that string is larger than 1, 2, 3 string. But if you compare the numerical value, 123 is greater than 23, right? Numerical order is opposite in this case. Okay? Numerical order is opposite to the alphabetic order. Yeah. Because they can be treated as both numerical values and string values. Yeah. So that's the meaning of this second property. Yeah. All right. Date and the time data type comparison. Yeah, we may also need to do date and time data comparison. Okay. Yeah. All right. So then for a less than comparison, an earlier date is considered to be smaller than a later date. And similarly with time. Yeah, that's natural. It's a natural order. Earlier, okay, smaller than the later time. Yeah. All right, so that's pretty simple. All right. Then properties for values of character string data type. Yeah. Some more properties. Yeah. A literal string value. Literal string value. Yeah. Yeah. So how do we first, it's case sensitive, literal string. Yeah. Uppercase, lowercase as a data, case sensitive. Yeah. Then placed between single quotation mark, apostrophes. This rule is by SQL standard. SQL standard is this one. SQL standard is for single quotes. Okay, but I also mentioned we can use double quotes. We can use double quotes for string values. Okay, yeah. It's not SQL standard, double quotes. That's the extension part. Okay, DBMS now extended to allow double quotes to be used. Okay, yeah. So, but it's not in SQL standard. Yeah. So when we talk about SQL standard, we use the single quotation mark for string value. Okay, yeah. All right. For fixed length strings, padded with blank characters to the right for shorter strings. Yes, fixed. Yeah. So if you do not provide that many characters, yeah, I said before, you'll probably get an error. Yeah, not error, padded, right? Padded with blank characters to the right, not to the left. Okay, to the right for shorter strings. All right. For comparison purpose, strings are considered ordered in alphabetic order. Yeah, because think about, you pad blank characters to the right. When you do string comparisons, then you compare first, you start with the first character, okay, then second character, and so on. Yeah. For comparison purpose. Yeah. All right. There is also a concatenation operator. In SQL, the concatenation operator is a double bar, double vertical bar. Okay? Yeah. In Java, our string concatenation, we use plus sign, right? Java, we use string concatenation plus sign. Okay? Yeah. In PHP, concatenation, string, we use dot operator, right? Dot, two string dot, that's concatenation in PHP. So you can see in different programming language, concatenation operator will be different. In our SQL, double vertical bar concatenation. Okay, yeah. All right, yeah, okay. So yeah, so that's the, today's lecture. 8 slides I prepared for today. Yeah. But we have about 10 minutes. I want to show you our case study number 3. Yeah. University example, I gave you case study number 1 and number 2. Yeah. Today, we have case study number 3. Yeah. I only add one small feature. Okay, yeah. Basically, the code change is not too much, only very little code change. Yeah. Okay, yeah. So let me switch to, I already set up, get everything ready. We just see the result. Okay, yeah. So that we use the same structure, yeah, different tables for the university. You can see for each table, I add 2 arrows, yeah, for 2 different directions, yeah, upper, down, up and down, 2 directions, okay, for each table, yeah. That means two-way sorting. Here, I add a feature for two-way sorting. The previous case study example, one-way sorting. Yeah. Here, I add two-way sorting. Okay. All right. So up, let's see, ascending order, descending. Yeah, up just ascending order. Yeah. For this particular column, down descending order. Okay. We sort descending order. For this table, up ascending order. Down descending order. All right. Yeah. This table up, yeah, ascending, descending. All right. Yeah. All right. Then I can change to a different table. I do the same thing. Yeah. Descending. All right. Yeah. Do the same thing. Ascending, descending. All right. And so on. Okay. Yeah. All like that. Yeah. The question is, we only want to change our code minimum. Yeah, we do not want to change too much code. Okay, as little as possible in our code change. Yeah, yeah. Let me bring up the code part a little bit. All right, this is the code part. Okay, all right. Look at, we used 3 parameters to control 3 different properties. The first, MN, to control table. Menu number, MN, that is the 5 tables, 0, 1, 2, 3, 4. The top bar, 5 tables, we use this parameter to control. Yeah. Which table you select? All right, yeah. CN, C, column number, okay, column number. When a table is selected, you also need to select which column you want to apply certain action on it. right? Apply certain action on it. Here, the sorting action. Yeah. We need to specify the field number, column number. So we use CN to get that. Then direction, DIR, the third parameter, control parameter, up or down, okay? Ascending or descending. So we use 0 or 1. If it is 0, ascending order. If it is 1, descending order. Here you can see we use 3 parameters to control 3 properties in this web application, okay? Then after we retrieve, when we do query, yeah, so you can see when we do query, order by, yeah, ascending or descending, yeah, look at this if statement. When dir variable value equals 0, ascending, yeah, ascending, we know it's default. So we just use order by, that's ascending, okay, yeah. If it's 1, not 0, yeah, so then we know it should be descending order. So we order by field name, then we add DESC, descending, okay, yeah, DESC at the end, yeah, descending order, yeah. So you can see the remaining code pretty much the same, okay, remaining code pretty much the same, yeah, all right, yeah, all right. But, so there is one place, one place. The JavaScript, remember, when we click the button, we call JavaScript. Yeah, look at that. When we click the button, on click, sort current field. We pass 3 parameters. We pass the first PHP parameter, second PHP parameter, yeah, that's the column number. The third 0, 1, okay, yeah. Ascending, we pass 0. Descending, we pass 1 to that JavaScript function. Sort current field, JavaScript function. Yeah, yeah. Let me get to, yeah, I still have 3 minutes. Let me get to the JavaScript function. Very simple JavaScript function, JS, okay. University JavaScript. Then in this JavaScript function, yeah, sort current field, yeah, very short, UVW for 3 parameter variables, yeah. Then we use document.location.href. We send a URL request. We send request to the server, yeah, you know, current server, because here we are running in the current server. Then unit 2 way sort.php question mark mn equals to the first variable u plus, yeah, here, yeah, look at concatenation plus in JavaScript plus concatenation, all right, double quotes ampersand cn equals to v, yeah, second parameter value. The third one, ampersand dir equals w value. This one line, that's enough to send this particular URL together with the query string. After question mark, you know, we call it query string, okay? Yeah, we send it to the server for data processing. Yeah. All right, data processing in our unit 2-way sort, we retrieve those 3 values, then we do the query, okay? And process the return the data. Yeah. So that is our case study number 3. Yeah. Okay. The reason here, these 3 case study examples I give you here to get you started on PHP programming with MySQL database. Then this weekend, I will assign you first programming project with the background from this university database and from these 3 case study examples. Yeah, because I will add features. For example, add new data, insert a row. For each table, you need to insert a row. Think about that. And you can edit each row, each piece. You click the button, you can edit individual piece of data. All right? Yeah. You can delete a row. All right? Yeah. So those simple features you add to the current example as your starting point. Okay, yeah. Then I will provide you a list of new features you need to add to our first programming project. Right. All right. So that's for today. Yeah. Yeah. So that's our part B. Yeah. Wednesday, part C. Yeah. So we have 4 parts. Yeah. All right. But this weekend, we will have first programming project. And our homework assignment will be coming up quickly. Yeah. Based on the timeline, after the first programming assignment, we will have our first homework assignment. Not, other than quiz, we have 3 homework assignments. So our first one will be coming up quickly. Okay. All right. So that's it. Yeah.